So, welcome to Math with Mike. So today we're going to start with the sigma notation. So as you can see, we have a plus b in parentheses to the power of n. And to start off, we're going to go over sigma notation. Looks like this, right? So there's a sigma notation. All this stuff is going to build up to this. So basically you have a plus b in parentheses, the power of n equals n combination 0, a to the n power times b to the 0 power. Anything to the 0 power is 1. So you'll see later that in some of these, you're just going to have, you're not going to see the a and b, you're just going to see the a. And then this is much like the sigma, this formula moves up in the numbers. So as you can see, it says n combination 1 times a to the n minus 1, b to the 1, plus n combination 2 times a to the power n minus 2 times b to the second power. And it keeps going. And the formula for that is n combination base n times a to the power n minus n times b to the n. And use the same thing going through each. So start with 0, then go to 1, then go to 2, then go to 3. And it's the same here. A plus b in parentheses to the n power equals n combination 0 times a to the n power times b to the 0 power. And you go 0, 1, 2, 3, all the way up to the n power, which gives you the sigma notation. Whatever n is, you keep going till you hit the last number. And then you can either take all of the numbers you get when you equate everything, and you can put it on a data sheet or whatever. So on the next problem, you have the sigma notation of n to the r equals 0 of n combination r equals 2n. So to find that, you just look at the formula a plus b in parentheses to the n power equals n sigma when r equals 0. Here we have n combination r times a to the n minus r times b to the power of r when a equals 1 and b equals 1. So when you plug in the a equals 1 and b equals 1, you get 1 plus 1 in parentheses to the n power equals 2 to the n power. And plugging it into the sigma notation, you have n sigma r equals 0, n combination r times 1 to the n minus r power times 1 to the r power equals n sigma r equals 0 to the n combination r. As you can see in this formula. And this is the formula we want to look at to get this. N combination r. You see this a lot in binomial series. There's a sigma notation and series are very similar because it's just tons of repetitions of numbers or integers and variables. So over here, we have 7 sigma r equals 1 for 2r minus 1. So you know that n equals 1, and r starts at 0 and goes up until you hit the number 7. So over here we have 2r minus 1. So 2 times 1 is 2, minus 1 is 1. And then 2 times 2 is 4, minus 1 is 3. Then 2 times 3 is 6, minus 1 equals 5. And you can see it here, 5, 7, 9, 11, 13. And it's the same down here. So you have 4 sigma r equals 0, 2r plus 1 over 2r. So if we plug it in, we'll get 2 times 0 plus 1 in parentheses over 2 times 0. And then you add 2 times 1 plus 1 over 2 times 1 plus 2 . 2 times 2 plus 1 over 2 times 2 plus 2 times 3 plus 1 over 2 times 3 plus 2 times 4. Now that we're at 4, we can end here and just calculate either the total number, or we can separate them into different segments of numbers. 2 times 4 plus 1 over 2 times 4. And this will give us 2 times 0 is 0, plus 1 is 1. And that's divided by 2 times 0, which is 0. So that's undefined. 1 over 0. Which we can just ignore. And then, because this started with r equals 1, you wouldn't even have to look at that. But I wanted you to see that so you could see similar to like a null value. So, and then you add it to 2 times 1 plus 1 is 3, divided by 2 times 1 is 2. So it's 3 over 2. 4 plus 1 is 5, divided by 4. 2 times 3 is 6, plus 1 is 7, divided by 6. 2 times 4 is 8, plus 1 is 9, divided by 8. And there you go. And next, we come down here to the factorials. 1 divided by 0 factorial. And I covered the factorials in an earlier video, along with the binomial series, which I was referencing earlier. So 1 divided by 0 factorial is 1, plus 1 over 1 factorial is also 1. Added together, that's 2, plus 1 over 2 factorial is 1 over 2, plus 1 over 3 factorial is 1 over 6. Because for the factorial, as you know, if you have 3 factorial, you have 1 times 2 times 3, which would give you 6. And that's what you put down here. And then if you look at 1 squared plus 2 squared plus 3 squared plus all the way up to n squared, and you come to and you want to find the sigma behind it, you go sigma, so it goes all the way up to n squared we have sigma n r equals 1 because it starts here at 1. And we have the r squared. Then, next page, we come to the sum of rational numbers. Sum of n rational numbers. So you have n sigma r equals 1 for r equals n plus n minus 1 plus n minus 2. Then when you have another sigma, you can actually add sigmas together. So you have n sigma r equals 1, r equals 1 plus 2 plus 3, all the way up to n. Normally the n stands for any number. Like if there was a 8 here, you do this n times, and then it would end. It's normally what you'll see on these problems. So when you add the two terms, you'll find that it'll be 2 is the constant, then you have n sigma r equals 1 for r, which would equal 1 plus n, because you take the 1 and add it to the n for the sigma, and then you have 2 plus n minus 1, that you have in two sigmas, and then 3 plus n minus 2. You can see that right there. So if n equals 4, you would have 2 as a constant, sigma 4 for r equals 1. So when you add those together, you get, you put the 4 in for the n's, all the n's. So you'll find that you get the same exact number every time you do that. And that's because that will happen even with the n notation. You're just going to get the same exact number. Moving on to rules for manipulating sums. For rule number 1, n sigma r equals 1, k f of r. K is a constant, and f is a function. So because r is in sigma notation, r equals 1, you get kf of 1 plus kf of 2 plus kf of 3 plus kf to n. And it just keeps going till you hit your n number, if you have one. So, and then you can even take that, because since k is the constant, you can pull it out, and you can just have the functions in parentheses. And you can take that and you can even make the sigma notation. So you pull the constant out, k sigma n for r equals 1 in the function r. So rule number 2 is you have sigma n r equals 1, and this is if you don't have a constant, and you have two different functions. So you have f of r plus g of r equals sigma n r equals 1 f of r plus n sigma r equals 1 g of r. So if we look at problem 1, where we have sigma n r equals 1, and then you have the two functions, 6r plus 5, right? So we have parentheses 6 times 1 plus 5 plus 6 times 2 plus 5 plus 6 times 3 plus 5 in parentheses, and then we do all that up to n. Since n is not described in this problem, we can just end it with 6n plus 5, or r plus 5. But we only go up n times, if that makes sense. So, 6r plus 5. And then if we want to find out what these are, 6 plus 5 is 11. 6 times 2 is 12, plus 5 is 17. 6 times 3 is 18, plus 5 is 23. And then you just keep going up. All right, next page. We're going to go over the exponential number e. So for the exponentials, you're looking at some exponential numbers like e to the power of 6 or 0.6 can give you a long number. So the reason that happens is because if you look at the limits from n to infinity of 1 divided by n, you'll find that it gets smaller and smaller and smaller until it hits 0. In the limit from n to infinity of n, you'll find that it'll get bigger and bigger an infinite number of times into infinity. So it's one keeps going lower, one keeps going higher. So low, high. So if we look at the limit from n approaching infinity of 1 over n, you'll get or 1 over n factorial, you'll get 1 over 0 factorial, which is 1. 1 over 1 factorial, which is 1. 1 over 2 factorial, which is 1 over 2. Plus 1 over 3 factorial, which is 1 over 6. And you keep going, and you get sigma for infinity, r equals 1. 1 divided by r factorial will give you the e. So it just keeps going up and it keeps getting smaller. So 0 plus 1 plus 2 plus 3 plus 4 plus all the way up to n with sigma infinity, r equals 0. The when r is 0, you have it here. R is 1, 2, 3, 4. And we look here, we'll have e to the x equals sigma to infinity, r equals 0, x to the power r over r factorial. So we know when r factorial is 0, that'll just give us, it's not there. So it'll give us a 1. And you have x and it's the same with the x. X to the power 0 is 1. Plus x to the r, when r is 1, you'll have x to the 1 power divided by 1, which is just x, plus x to the power of 2 divided by 2 factorial, which is 1 over 2x squared, plus x to the 3rd power divided by 3 factorial, plus x to the 4 power over 4 factorial. And you can look at the factorials, and 3 factorial is 6. 4 factorial is 4 times 3 is 12, times 2 is 24. And depending on what the x is, it'll just get smaller and smaller and smaller as it goes up, which will lead us to the limits. And you'll even find that when you start integrating and doing derivatives, that you'll see the limits along with it. So I hope you enjoyed this video. More videos to come. We've already talked about binomial expressions, binomial series, the sigma notation, exponential number e, and maybe next time we'll go over integrals. We've gone over the quadratic equation, so we can just combine all this stuff up and into the new lesson. So hope you enjoyed it. Have a good one.